Hey everyone, it's Kenny again with Advanced Network Solutions. We are an IT service provider outside of Gerald, Missouri. We service a 50-mile radius from our location. If you need IT services, give us a call or contact us on the web. Now, last week we did a video about Wi-Fi, and every time that I upload one of these videos, I start seeing videos kind of related to the videos that I'm uploading in my suggested feeds. And so sometimes I watch some of these and sometimes I just skip right over them. But I watched some of the ones on Wi-Fi signals. And one of the things that I realized is I didn't really talk about placement. Where do you put your Wi-Fi router? Where do you put your router in your house to get the best coverage? And I also was watching some of these videos and started reading some links that just have some really bad misinformation about how wireless signals work and how they travel. Like the one that I ran into and kept running into is this idea, if we grab our router here, that wireless signals from the router travel out and down. I don't know where this came from, but wireless signals from your router don't travel down from the router. First of all, wireless signals are omnidirectional. They travel, almost think of it like a sphere in a three-dimensional field. They travel out from the router in all directions. Okay. Where the issue was is they started talking about beaming and things like that, and I don't know where people get this misconception that wireless signals travel down from your router. First of all, if you think about it, that wouldn't even make sense. There's nothing inherent about wireless signals, because basically wireless signals are actually radio waves. Radio waves aren't really that affected by gravity or anything like that, so there's no reason that they would naturally travel downwards. There's also no reason that a company like Netgear or Cisco or anything would design a router to broadcast signal down. Okay, remember, the signal's broadcast omnidirectional. But what happened is, that's naturally. What happens is, there are two ways as you get these routers and you put them in bigger and bigger houses, or you have just more obstacles. You know, there's things in the wall, obstructions, furniture, things that kind of obscure the signal. One of the worst things is water, and especially if you have water pipes in your wall that are copper, because two things happen. Metal reflects radio waves, not entirely. Some of the radio waves will pass through it, but a good chunk of it will be reflected. Water absorbs radio waves. So if you've got water pipes in your house, those things kill electric signals, or wireless signals. But you'll also hear all these other things about all these other materials that affect wireless, and they do. You know, the construction of your house, what it's made out of, if you've got metal studs, if you're in a business environment. People try to bring up insulation. First of all, interior walls aren't actually insulated in most cases. There's very few reasons you would ever have interior walls insulated. It's not something that happens, mostly because it's harder to heat buildings evenly if you've got every single room individually insulated. Not only that, it's extremely expensive. Your exterior walls will be insulated, but unless you're trying to get wireless signal outside, that's not really a big issue. The construction of the exterior of your house will matter. Brick homes have a harder time getting Wi-Fi signals on the outside of the homes or out in the yard and things like that. They have a harder time as opposed to like vinyl and things like that. But back to signals. Now, I don't know where this idea came from that wireless signals travel down. Again, as I've discussed, that's not an inherent property of radio waves. But if you think about it from a design standpoint, what happens is, as I said, omnidirectional. They broadcast in a sphere, basically. You can think of that way. But as your houses get bigger, you have all these other materials that start to block signals. Companies wanted to come up with a way to get boosted signals, to basically cover a larger area. there's basically two ways to do this, because what happens with radio signals is this thing I kind of alluded to in the last video, is this thing called attenuation. The further out from the source you get, the weaker the signal, and that's just because naturally the energy starts to die out and the signal isn't as strong on the outside of the signal range as it is on the, close to the router. So attenuation, in order to combat attenuation, what they do is they had two options. You could either boost the amount of power drawn by the device to push the signal out further, but the problem with that is what that translates to to residential users is more power consumption. Now, with a lot of people being mindful of the gold standard ratings and energy efficient devices and all of that, it really wouldn't make your device look good from a sales marketing standpoint to draw more power and cost the end user or the residential user more money. So they developed this technique called beaming. And what beaming is, and people see these little illustrations drawn of beaming, where you've seen the Wi-Fi illustration where it's 3 little marks or 4 little marks and then they come out in both directions. That's not really a good representation of how beaming actually works. You can think of it, instead of being a sphere, okay, it's not like the radio waves are actual beams that only travel in one direction and you've got to be inside of that beam in order for it to work. You can more think of it as it's still a sphere, but it's focused. So you might have like an oval type signal coverage area as opposed to a perfect sphere. And what that does is whenever they focus it, they're not worried about actually sending signals up or down as much as they are as getting them out. And there are some advantages and disadvantages to different types of routers. I personally like the Nighthawks and the new higher end routers that are coming out that have the antennas on them, because you can kind of point those in and out, adjust them so that different beams are going in different directions to get the most coverage, upstairs, downstairs, in the basement, things like that. But these videos that we're talking about how Wi-Fi signals travel out and down, and they tried to use the example of cell phone towers. If you think of cell phone towers, they're 100 feet tall, and that's for a reason, because they broadcast out and down. The reason cell phone towers and radio towers are so tall is because that way they can get over the obstacles that block signal, like metal buildings and hills and trees. It has nothing to do with this idea that radio waves emit downwards. Okay, it really depends on how the antenna is designed. The radio waves will emit in whichever direction you push them. And if you think about from a router standpoint, okay, this is going to sit on something, right? Like a table, a desk, and for these people arguing you need to put your routers up high, you're going to put them on a shelf, maybe on top of your refrigerator, and it's going to sit, wherever you're going to put this, it's going to sit on some type of physical platform that inherently, by nature, blocks or obstructs Wi-Fi signals. So why would you design it to broadcast down? That doesn't make any, and Netgear and these companies, they know that. Also, another thing, being a cable installer for a while, I worked with Charter. If you think about how those service providers come into your house, they come in down low. Most devices, whenever you go into homes and you troubleshoot routers and stuff for people, 95% of the time, their routers are placed below waist height. And there are natural reasons for this. First of all, they're going to sit on usually a desk or a counter or something like that to where they're not up really high. Most people don't put shelves and routers and things like that up really high. And the reason is not because of they're thinking about signals or anything like that. The reason is because if you think of how cable companies come into your house, they come in down low. Most of the cabling has to go through the crawl space or through the attic. And typically they go through the crawl space just because it's impossible to work in attics whenever you're in a hot environment. If it's 95 degrees outside, it's 115, 120 degrees up in the attic with still air. If you contract like Charter or something and say, hey, we need some cable run, you're going to have to be up in the attic, they're going to tell you they're going to do it in the early morning, and that's when you're going to schedule. They will not do it in the afternoon because the heat issues. Now, if you think about how houses are built, you can't drill through foundation, right? You can't drill through concrete for structural reasons, and if water starts to seep in there, it will destroy concrete. But so what happens is you have your foundation, even if you have a basement, right? That exterior concrete wall is still your foundation, and on top of that you have a base plate, and that base plate is where people drill in, and on top of that is your first level floor. So your ISP usually comes into your house with their service fairly low to the ground, and then they might run it up through the wall, and usually you're going to get an outlet or some type of wall plate that's going to be at the same level as your wall outlets, just to keep everything uniform. So like I said, Netgear and these guys, they're aware of all of these factors, and they don't design their routers to broadcast downwards when they know 95% of the time this thing's not going to be more than 3 or 4 feet off the ground. Now, some people claim that they have fewer signal issues in more rooms whenever they put the router up high, but that's not because the signal's broadcasting down. That's because of something like I was mentioning earlier. You have furniture in the way that absorbs signals. If they're sitting too low, you have, like, let's say if your router's installed in this room over here, and you're over here, and you're in, like, there's a room or a wall between you, okay, and on this side of the wall is your kitchen or something, and you've got water pipes coming up between you and where you're at in the kitchen in the next room, those water pipes will kill Wi-Fi signal. Other things like air conditioning ducts and things like that they'll affect it, but they're not going to be too bad. Water pipes, water is a major killer for Wi-Fi signals. But I didn't want to just come on here and start spouting out my opinion. So what I did was I tested this. Okay, so I went into, actually borrowed my brother's house and went in with a couple of different routers and used a couple of different devices. What we did is we went into the house, we tested all of the Wi-Fi signals in all the different rooms, and then we took the routers to see if they really broadcast down, and we flipped the devices upside down. We checked in the basement, we checked upstairs. In both orientations, took signals in every room with 2 different routers, plugged in at different times. I know that I could have put them on different channels to avoid interference and stuff, but I literally, like, plugged one in, tested all the rooms, flipped it upside down, tested all the rooms again, turned it off, plugged the next router in, tested all the rooms, flipped it upside down, tested all the rooms, and compared signal levels. Now, the 2 devices that I tested were my brother's Nighthawk R7000 and a Sagemcom Fast 5260. Both of them have the 2.4 and 5 gigahertz band. I tested them, like I said, with 2 different devices. Unfortunately, the second tablet that I have doesn't have 5 gigahertz wireless NIC in it. I could only test the 2.4 gigahertz band with the second device. But the interesting thing is to kind of look at here is we got different levels with my cell phone testing the signal levels and the tablet that I was using testing the signal levels on the 2.4 gigahertz band, and there's a reason for that. Like I said, your Wi-Fi is actually radio, and they kind of work just like shortwave radios do. Your handhelds. It's a two-way communication. So the wireless cards inside of the devices that you're using, like laptops, cell phones, tablets, all of those other things, whatever you have a wireless card in, they have almost as much to do with the signal level and speed and communication. In fact, with speed, they have as much to do as the wireless router. So you're going to get different levels, different speeds, different quality connections on Wi-Fi with different devices depending on what wireless NICs are in them. And you can kind of see that here, that there are, we got different signal levels here on the 2.4 gigahertz band. And the weird thing is it isn't consistent. Like as we walked into different rooms, one device would have a better signal than the other, and then we go into a different room and that reverses to where the second device that had the worst signal in the first room has a better signal. One of the things that you can see here is test 1 is with the devices right side up. Test 2 was with the devices upside down. So whenever we're right side up here, as you can look, we got better overall signals in the basement, okay, than we did upstairs. When we flipped them upside down, the same thing is kind of true here, although our signal levels upstairs got worse, which will kind of prove the point that Wi-Fi signals do not broadcast in a downward direction from your router, and sticking them up higher isn't necessarily going to give you better signal. The takeaway that you should take from this is that people said, well, putting them in you'll read out there, put them in the center of your house, which is true because that's going to give you about the best coverage. But there's the other caveat to think about isn't elevation. Okay, if you've got a basement and an upstairs, you probably want to put it on the main level so that you have decent coverage upstairs and in the basement. But you also, if your house is really big and you've got 3 levels like that, you may want to actually consider getting some repeaters. Now what repeaters do is they pick up the wireless signal from your router and they amplify it and then rebroadcast them back out. When you do this, make sure that your repeaters are on different channels than your main device. This will not affect the device that it's talking with, but you will end up with a lot of collisions if your repeaters are on the same channels as your the router itself. And in fact, you want these repeaters to kind of overlap signal to give you the best results, but you definitely need them on different channels so that you're not experiencing a lot of collisions. And basically what collisions are, they kind of like what it sounds like whenever routers and devices communicate with each other, they break the information and data that they're sending up into what are called packets, and they send out, like a single file, for example, is sent out in a multiple packets, and these packets will, if they're your wireless router on the Wi-Fi side, they only take in like 1 packet at a time. You know, only one person can talk, one person can listen at a time, or one person can talk at a time. And so what happens if it receives 2 packets at once, it drops them both, and that's known as a collision, and then those packets have to be resent. And then that ultimately slows down your internet speeds and things like that, so your network speeds, all of that stuff. So make sure that if you're going to use repeaters, you definitely set them to different channels than what your router is. And if the repeaters signals are overlapping, you want them on separate channels from each other as well. So one example might be to put like your router on channel 5 and then the next one on like channel 8 and then the next one on channel 10, or depending on, just kind of try to space them out. If you're testing signals, there are apps that you can download to test Wi-Fi signals. I'm not sure about Apple, but I'm sure they're on Apple. I use Androids, but you just go to your app store and you search for Wi-Fi Analyzer, and you'll download one of those apps, and they'll show you what your Wi-Fi signals are, the strengths. The good ones will show you which channels that they're on, and so you can make sure that all your devices that are broadcasting wireless signals are on different channels. Now you can kind of pause this video if you want to and go over some of these numbers, but as you're going over these, just kind of keep in mind, don't get too caught up if you're looking at like test 1 versus test 2 on a single device and you see a difference of 1 or 2 decibel milliwatts. 1 or 2 decibel milliwatts. First of all, every reading on here that I took, I had to sit there for about 30 seconds to kind of get a good reading because these fluctuate. And so what I had to do is just kind of sit there and look at each device and wait for it to kind of, if you start moving around, like you take a couple steps or you're waving your device up and down, this is going to fluctuate up and down. So you kind of have to, I had to sit there and wait for them to level out. Seeing a difference in 1 or 2 decibel milliwatts it doesn't really tell you anything. So don't get too caught up in seeing 1 or 2 little decimal milliwatt. You don't notice that difference, first of all, as you're just sitting there browsing the internet and it fluctuates that much. You're not even going to be able to tell. If if you're able to boost it by 1 or 2 somehow, you're not going to see a difference. That little bit of a fluctuation doesn't really mean anything. So whenever you're looking at that, it is kind of neat to see that there's a difference whenever you flip them upside down versus right side up. But it's very small, it's very subtle. So the takeaway that you should get from this is that try to center your router in the center of your house, but also keep in mind the structure of your house, material that it's made out of, whether you've got like mirrors will reflect signals. Not real crazy, but water pipes, that's the big thing to keep in mind is water pipes, especially if you have copper as opposed to PVC water pipes. Not that I don't think that will make too much of a difference, but just water pipes in general, just kind of keep in mind, if you've got a room between you and your router that you're in a lot, that you want to use Wi-Fi a lot, kind of think of where those water pipes are in your house, and rather than having it perfectly centered in your house, depending on how the way your house is designed, where those pipes are, things like that, you may want to shift over one room, or maybe raise it to where it's depending on how high up those water pipes come, if they're in between you and the room that you're going to use this device in a lot, you may just want to move it to the other side of the wall, move it to the next room, and you're still fairly central in your house, but just kind of keep in mind, keep it kind of center of your house. That's going to give you the best overall coverage, but keep in mind the structure, the way your house is designed, the architecture, things like that, and kind of position it into a place where you're not going to have a lot of interference with things like that. So that is the takeaway. Again, Kenny with Advanced Network Solutions. If you like our videos, subscribe to our YouTube channel, leave comments below on videos, material you'd like us to cover, and we'll do our best to cover that material. You can follow us on the web, and thanks for your time. You guys have a great day.